Hello students, how are you? कैसे तैयारी चल रही है? Welcome to my channel. If you have not subscribed my channel yet, please subscribe it by pressing the subscribe button. बहुत लोग चैनल देख रहे हैं लेकिन सब्सक्राइब नहीं कर रहे हैं. Please subscribe the channel. Now I shall discuss about some basic concept of chemistry. Today I shall discuss about some basic concepts of chemistry. In this unit, I shall discuss about atomic and molecular masses. One of the basic and important topic. This is atomic and molecular masses. We know that atoms are very small, therefore their masses are extremely small. Nowadays, the atomic mass or mass of atom is determined by a sophisticated technique known as mass spectrometry. It is known as mass spectrometry. This technique is used to determine the mass of extremely small particles such as atoms, molecules, etc. The details of this technique you will study in higher classes. In 19th century, the atomic mass was given on the basis of hydrogen. Since hydrogen is the lightest element, its atomic mass was assigned equal to 1 and the atomic masses of other elements were given relative to it on the basis of hydrogen scale. But nowadays atomic masses are given on the basis of carbon 12. Atomic masses are given on the basis of carbon 12. Here carbon 12 is taken as standard for giving atomic masses of different elements. Carbon 12 is an isotope of carbon represented by 12C. It is an isotope of carbon. The mass of one carbon 12 has been given equal to 12 AMU. The mass of one carbon 12 element is given as 12 AMU. Here AMU stands for atomic mass unit. Here AMU stands for atomic mass unit. Atomic mass unit may be defined as 1/12 the mass of one carbon 12 isotope. It is defined as 1/12 the mass of one carbon 12 isotope. 1/12 of mass of carbon 12 atom. 1 mu is equal to 1/12 of the mass of one carbon 12 atom. In grams, 1 mu is equal to 1.66056 into 10 to the power minus 24 gram. 1 mu comes out to be 1.66 into 056 into 10 to the power minus 24 gram. Now the mass of one hydrogen atom has been determined by mass spectrometry. The mass of one hydrogen atom has been determined by mass spectrometry technique and it comes out to be mass of one hydrogen atom 1.6736 into 10 to the power minus 24 gram. And 1 mu, as I have discussed here, 1 mu is equal to 1.66056 into 10 to the power minus 24 gram. Now the mass of hydrogen atom, in AMU scale, the mass of one hydrogen atom in MU square is equal to 1.6736 into 10 to the power minus 24 gram divided by 1.66056 into 10 to the power minus 24 gram. This is the mass of one hydrogen atom. This is 1 mu in grams. This comes out to be 1.0078 AMU, which is approximately equal to 1.008 AMU. Therefore, the mass of one hydrogen atom in AMU scale is equal to 1.008 atomic mass unit. Now, atomic mass unit AMU is abbreviated as U. AMU is written as U for simplicity. U represents unified mass. Here, U represents unified mass. In place of mu, we simply write U. U represents unified mass or atomic mass unit. On atomic mass unit, the mass of oxygen, one oxygen atom, oxygen 16, comes out to be 15.995 U, which can be taken approximately equal to 16.00 U. On atomic mass unit scale, mass of one oxygen atom is equal to this much. Similarly, mass of carbon atom is 12.011 U, unified mass on atomic mass unit scale. So I have discussed about atomic masses. Earlier, atomic masses were given relative to the atomic mass of hydrogen atom. Now, atomic masses can be determined by sophisticated instrumentation techniques such as mass spectrometry. Nowadays, atomic mass is given on the basis of carbon 12 atom. 1 mu stands for 1.66056 into 10 to the power minus 24 gram. Mass of one hydrogen atom in mu scale comes out to be 1.008 mu. At one atomic mass unit is equal to 1/12 the mass of one carbon 12 isotope. Now I shall define about molecular masses. Now we shall discuss about molecular masses. What is molecular mass? Molecular mass. What is molecular mass? Molecular mass can be defined as sum of atomic masses of different elements present in a molecule. Molecular mass can be simply given as the sum of atomic masses of different elements present in a molecule. It is obtained by multiplying the atomic mass of element by the number of elements and adding them together. For example, we can determine the molecular mass of methane. CH4 is known as methane. It is gas. We can determine the molecular mass of methane. The molecular mass of methane is equal to 1 into mass of carbon. Since in methane molecule there is one carbon atom, plus 4 into mass of hydrogen atom. Since in methane molecule there are 4 hydrogen atoms, so we multiply mass of one hydrogen atom by 4. Mass of one carbon atom in mu scale is 12.011 plus 4 into mass of one hydrogen atom is 1.008 U. After addition, the mass of methane comes out to be 16.043 U. Therefore, the molecular mass of methane is equal to 16.043 U, unified mass or atomic mass unit. Since in methane there is one carbon atom and four hydrogen atom, so in order to determine the molecular mass, we simply write the mass of each element and multiply by their numbers, and after addition we get the molecular mass. Similarly, we can determine the molecular mass of water, H2O. Molecular formula of water is H2O. Here, two hydrogen atoms are present, therefore 2 into mass of hydrogen, atomic mass of hydrogen, plus 1 into atomic mass of oxygen. 2 into mass of hydrogen is 1.008 plus 1 into 16.00 U, unified mass. It comes out to be 18.02 E. Therefore, the molecular mass of water molecule is 18.02 U, or unified mass. Similarly, we can determine the molecular mass of glucose, C6H12O6. The glucose has molecular formula C6H12O6. Here 6 carbon atoms are present, 12 hydrogen atoms are present, and 6 oxygen atoms are present. Therefore, the molecular mass is equal to 6 into mass of one carbon atom. Mass of one carbon atom is 12.011 plus 12 into mass of one hydrogen atom. The mass of one hydrogen atom is 1.008 U plus 6 into mass of one oxygen atom. The mass of one oxygen atom is 6.00 U. After multiplication and addition, we get the molecular mass 180.162 U. Therefore, the molecular mass of glucose is 180.162 U. It has molecular formula C6H12O6. There are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. We simply multiply the atomic mass of each element by their numbers, and after the addition we get the molecular mass of glucose. So today I have discussed about atomic masses and molecular masses. Molecular mass is given by the sum of atomic masses of different elements present in the molecule. We have taken the example of water, methane, and glucose. Thank you for watching my channel. Your comments are welcome. You can suggest me any other topic you want to discuss in next lecture. Thank you once again.